So section 3.3 is going to focus primarily on the slope of a line, and we're going to build on this in the following section, so make sure you kind of have this as your foundation, the plotting points, seeing the tables, and understanding what the slope of a line is. When we're talking about the slope of a line, there's going to be four primary ones that we're going to be dealing with. Really the first two are the ones that we need to focus the most on. A positive slope is where the line is going uphill, and think about if you were walking it and we read a line like we read a book from left to right. So if I was walking this uphill, right, I'd be breaking a sweat. Going uphill is a positive slope. A negative slope, once again, think I'm reading it like a book, left to right, okay? Chances are I'm not very sturdy, so I'd be falling, and that's why I have that, but that is we'd be going downhill. That makes it a negative slope. A slope of 0, that's a nice calm walk. That's just, no stress at all, no up, no down. Slope of 0 is where it's flat, straight across. We've seen that already when I have a y equals a k, y equals some number, okay? So a y equals 2, y equals 3, whatever it is, that's what this equation is, and it gives us a slope of 0. Or we can have an undefined slope, and that's where it's a vertical line, okay? And that's where x equals a number. And notice I can't walk up this, right? Right? The idea is if you were walking up this, you'd have to have like glowing red eyes, and you call an exorcist, because that's not cool. You don't walk up walls like that. That's why it's an undefined slope. That is not a slope. Your car does not drive up walls, right? So this is an undefined slope. That's when x equals a number. That's a vertical line. And we're going to see why, not just kind of have this, but we're going to see why this is true. But those are the four primary slopes you need to focus on. We talked about slope already as rise over run. I'm sure you've heard that phrase before. Rise being the change in values up and down. Run being the change in values left and right. So if I asked you all to rise, you would all what? Stand up. If I said, unrise, you'd sit down. No, it doesn't make sense. But rise is our up and down. Run, we run left and right. Okay? I talked about this prior as well. The rise is our change in the y's. So rise is y's. The run is the change in the x. I like to use the symbol for change. That's this little delta. It's a triangle. But delta y over delta x. That delta just stands for change. Okay? Mathematically, they're going to give you a formula. So if you really like formulas, here you go. Okay? How do I get the change between two y values? Right? Well, you subtract them. I would take the second y value and subtract the first y value. And that would give me the change between those numbers. If I want the change in the x, I would subtract them. The second x value minus the first x value. And that would give me the change in those. Okay? So it's going to ask me for the slope between points. So for instance, here's the slope between 2, 3, and 6, negative 1. What bothers me is yes, there's going to be a formula for this, but you could physically plot these points and see the slope. You could plot 2, 3, put a point there, 6, 4, 5, 6, negative 1, and I could visually find the slope between these 2 points. I already know, just based on what it looks like, if I were walking this, it would be a negative slope. It's going downhill. In fact, if I think of slope as, what was it, change in y over change in x, y is the up and down. Between these 2 points, how far up and down do we go? Well, we go down 1, 2, 3, 4. We go down 4. And then we go to the right. 1, 2, 3. Is it 4? I think it is. Yep. So I can say the change in y is the change up and down is negative 4. Divided by the change in x is the change left and right is 4. This is a slope of negative 1. Okay? That's just a simplified form of the slope. That means if I go down 1, right 1, down 1, right 1, down 1, right 1, that I'll keep following that same line. It's just a simplified version of the slope. Okay? So I'm going to encourage you that, if you're not liking the formulas, do it visual. Make this visual. If you do like your formulas, well, then you need to number each of these. This is x1, y1, x2, y2. And when I go to my formula, I've got to take y2, negative 1, minus y1, 3, over x2, 6, minus x1, which is 2. And I get negative 1 minus 3 is negative 4, divided by 4 is still negative 1. Now be careful, the order here matters. I cannot put the negative 1 here and then put the 2 first. You'll get yourself in trouble. You could actually, if you switch the order and put the 3 first, if you did 3 minus negative 1, it wouldn't necessarily be wrong as long as you switched the order on the bottom, as long as you started with the 2 minus 6. Because what you would end up there is with positive 4 on the top and a negative 4 on the bottom, and positive 4 divided by a negative 4 is still a negative 1. Okay? So either way, as long as you keep it in the right order, whatever point you start with here first, you start with the same point on the bottom, and that should be fine. If you feel like that was way too confusing, then just always start with y2 and x2. Slope between negative 1, negative 4, and 1, negative 1. Okay? Negative 1, negative 4 would be 1 to the left and 4 down. 1, negative 1 would be 1 to the right and 1 down. What is the slope between these 2 points? I'm going to guess visually that this slope is going to be a positive slope. I'm going to count change in y over change in x. I went up 3 jumps. I went right 2 jumps. Do not make this 2 over 3. It's the y over the x. So the change in y over the change in x, and this is a positive slope. Now some people are like, well wait, what if I went down and left? Well, that would make that a negative 3, and that would make that a negative 2. Does that change our slope? Well, if the change in y was negative 3 and the change in x was negative 2, is that still a positive slope? Well, a negative divided by a negative is still positive. So this is where, with a positive slope, I can have 2 positives, or if I have 2 negatives, it's still a positive slope because they cancel to make that positive. Using the formulas, y2 would be negative 1 minus y1. This is where I catch a lot of people in the formula, so it would be minus a negative 4 over x2, 1 minus x1, a negative 1. This becomes negative 1 plus 4, which is 3, over 1 plus 1, which is 2. 3 over 2 still. Same slope. Okay? If you like the formula, use the formula. It doesn't hurt my feelings. I like to make things visual. I'm actually going to look between these 2 points, and I can find the slope real quickly by going, look, the y value was negative 4, it's negative 1, it went up 3. I can do that mathematically. If you're not like that, use the picture, use the formula, use what works for you. A couple of examples. Okay, and I'm going to keep doing both where we can sketch them or we can use the formula. So y2 minus y1. Our y2 this time would be minus y1 over x2 minus x1. What is 4 minus 4? This becomes 2 plus 5, or 7. 0 divided by 7 is 0. This is a slope of 0. This should actually make sense when we draw it. Negative 5, 4 is 5 to the left and up 4, and 2, 4. And notice if I draw that line is what? Flat line, slope of 0. When the slope is 0, okay, if our slope is 0, what that means is it will be 0 divided by any number will give me a slope of 0. Remember, our change in y is constant at 0. We don't go up or down at all. That's what a slope of 0 is. This next one, if I do the formula again, y2 minus y1 gives us, I think, negative 6 over x2 minus x1, negative 6 divided by 0. Anything divided by 0 is undefined. This is a undefined slope. Visually, what does it look like? If I go over 6 and up 2, or go over 6 and down 4, this is a slope that is vertical, straight up and down. It is not defined. You are not walking on this, right? Okay. So an undefined slope will be if I have any number on the top divided by 0. We can't divide by 0. That makes it undefined. The last thing, and we're just going to kind of introduce this, and then we'll play with this more in later sections, but you need to know what parallel and perpendicular mean. Now, in the geometry, that's easy. Parallel means two lines never cross. What does that mean in algebra? Well, if they never cross, then they have the same slope. They rise and run the same amount. They never get any closer or any further apart. Hence, they never cross. But for that to occur in algebra, they must have the same slope, different y-intercepts. So if our slope 1 is a over b, and they say we have another line where the parallel, or where its slope is parallel, the second one's slope will also be a over b. So in the situation where I've drawn this, our first slope would be, looks like 1, 2, 3, 4, 5 over 2. So the first slope would be 5 over 2. And the second one, if it's parallel, should also be the same. So 1, 2, 3, 4. My picture sucks. All right. Oh, you know why? And I'm going to fix that because it doesn't look good at all. Point was right here. So it's up 4 over 2. Up 4 over 2, or a slope of 2. This other one should have the same slope. So M2 should be up 2 over 1, up 2 over 1, up 2 over 1. It has the same slope. Okay? All right. This one, if they're perpendicular, they're not the same slope. Okay? Specifically, this one has a slope again of up 2 over 1, up 2 over 1, or the up 4 over 2, depending on how you look at it, right? For the second one to be perpendicular, it doesn't just cross, it has to cross at a right angle, or a 90-degree angle. How does that occur? Well, the slope cannot be the same. If the one slope is positive, for the other one to be perpendicular, the other one has to be opposite, negative. And reciprocal. It has to have both. A lot of people will just flip it. A lot of people will just make it negative. It has to be both. So A over B becomes negative B over A. 2 over 1 becomes negative 1 over 2. Negative 1 over 2, negative 1 over 2. Okay? So for these to be perpendicular, the slopes are not the same. They are opposite and reciprocal. If one is A over B, the other one is negative B over A. If the first one was negative A over B, the opposite would be positive B over A. They are both opposite and reciprocal. So that's, like I said, just kind of an introduction to slopes. And I was going to do one more thing. Let's see. Just real quick. If I have an equation, and these are the 2 points. Let's do negative 1, 3. And 2, 0. What is the slope? Okay. Well, I can do that visually. The change in y is down 3. The change in x is over 3. So it would be, which is negative 1, right? Down 1, right 1, down 1, right 1, down 1, right 1. That's the same. There's our slope, okay? What would a slope parallel to that be? Well, if I wanted to draw a line that was parallel to that, then our second slope would have to be down and right the same amount. It would also be -1. What if I wanted a slope that was perpendicular to either of these? I want a third line, let me change the colors so I don't get too confusing, that not only crosses, but crosses at a 90-degree angle. Well, I know that the first slopes were both negative, so this one, to be perpendicular, would have to be opposite, positive. Now what's interesting about this one is if I flip 1, because these are both really like -1/1, if I make it positive and I flip it, it's still 1/1, or just +1. Okay? So that's really everything they're having us do. Find the points, the slope between 2 points, and then kind of discussing what a parallel or perpendicular slope would be.